Okay, this is going to be chapter 11 on coastal systems and wind processes. So it's kind of a two-part thing, one on the oceans and the coastal processes, and then also one on the wind, which we can compare to previous chapters on I'm sorry, on rivers, and the following chapter on glaciers. So it's kind of the same process in the sense that how they change landscape. Okay, so again, this is one that's heavy on animations and videos over in the chapter module on Canvas. So I'm going to hit the highlights on the lecture, and I'll direct you to the videos and animations you need to watch to prepare you for the test. Okay, so let me go over to share screen here, and we'll just kind of run through the beginning parts here about oceans and seas and what they are. You know, the ocean is larger than seas. Seas are often partially enclosed by land. So know these various terms, what gulfs are, and what bay and coves are. Oops, went too far. So there's, you know, our various oceans there: Atlantic, Pacific, the Indian, the Arctic, and then the Antarctic down there. So those were the main oceans there. But then the seas like the Mediterranean Sea, Black Sea, Caspian Sea, for example, Caribbean, and then our gulfs like the Gulf of Mexico, Gulf of California. Those are the ones that, you know, affect our weather predominantly here. So again, you should know where these are. The Pacific is by far and away the biggest. Okay, so keep that in mind. Just zooming in on the Mideast here. So here's the Mediterranean, Black Sea, Caspian Sea, which is actually more of a giant lake, but it's they call it a sea. Notice the Gulf here. Here's the Red Sea, the Gulf of Aden, and the Arabian Sea, Indian Ocean. So you have all these different forms, you know, right here in this one slide. So that's a good way to look at this. Now, one of the important things about seawater is the chemistry of it. We know that water is a universal solvent, okay? And I want to check and make sure I got a video for that. Yeah, and so the elements that are in the ocean are generally dissolved solids, and they come from natural elements and compounds. And the 99% of those is chlorine, sodium, magnesium, sulfur, calcium, potassium, and bromine. And if you know, of course, sodium is one of the elements there that make it salty. So in a typical gram of water, or 1,000 grams of water, if you will, it's 3.5% salinity, salt. So out of that, out of the 1,000 grams, 35 grams are salt. And out of those, the bulk of it is sodium and chloride. That's your salt. And then with these lesser ones in there as well. So again, this will change, okay? So if it's greater than 35 parts per thousand, it's what we call brine. If it's less than that, it's brackish. So as we get near land masses, the water drops, the salinity of the water drops below 35 parts per thousand. And in other parts, especially where it's hot, where the water's hot, it tends to be a little saltier. It always depends, again, on the variations in the atmospheric conditions. So here's ocean surface salinity. So the orange and red are the more salt is in it. You can see in the Atlantic. So the Atlantic is more saltier than the Pacific. And over here in the Mediterranean, for example, and over here in the Indian Ocean, you can see higher levels of salinity as well. And there in the Gulf of Mexico. And notice where it's cold, up here down the coast of North America, and near the coastlines, especially, it's less salty. So that's, you know, again, due to the fact that you're getting runoff from land masses. We're changing this because of human-induced climate change, which is melting ice, which adds more H2O into the water, so it increases or decreases the salinity of it, and allows for more carbon dioxide intake, which increases ocean acidification, which contributes to the bleaching of coral. just another way to do this, where water absorbs carbon dioxide from the atmosphere, so the oceans become more acidic. You notice where the coral reefs are, we tend to get these high levels of CO2. And notice, this is 2005 and what's expected in 2050. So we expect these changes. And that will reduce the calcium carbonate that the coral needs to build its shells. And so we'll see a dramatic decrease in coral. And this is an ongoing problem now that a lot of nations face with their coral preserves, especially over there on the Barrier Reef in Australia. Okay, so let me stop here at part 1, and then we'll look at part 2, which will cover ocean layers.